So today we're going to investigate characteristics of quadratic functions. How did you know that? It says that on the paper, but it also says it on the board. And you already copied it down into your notebooks, didn't you? Excellent. I'm so proud of you. Okay, consider the quadratic function. There. Okay. Use a table function of a graphing calculator to make a table of values for a domain of all integers from -3 to 5. What the heck does that mean? Use the table function. Okay, we got our calculator, right? So we need to turn it on. We need to go home. Not actually go home, because we already had that discussion how we always want to go home. That's fine. But press the home button. Let's open a new document. No, we don't want to save the old one. And we want to open a graph, right? Okay. So, what are we going to put into our function? Does Emilio have one? See if he has one. Okay, so x squared minus 2x minus 3. Thank you. And now when we hit enter, there's the beautiful graph for us. But I need the table. How? How do I go to my table? Control T. Okay, excellent. Is there another way to get to your table, by the way? Menu, blah, blah, blah. We know the shortcut, though, right? Okay. So here's our table. What do I record over here? It tells me in my instructions. Make a table of values for a domain of all integers from -3 to 5. What does that mean? Domain is what? My x's. So I need to start at -3. Do I have to do -2.5? How do I know that? Because it says integers, right? It just wants the integers, not any decimals or fractions, just integers. -1, 0, 1, 2, 3, 4, 5. And amazingly enough, there's exactly enough spaces to go from -3 to 5. Coincidence? I think not. Okay? We clearly are that awesome. Yes. Plot the points on the coordinate graph below. Okay, so we need to get those points out of the table. So I need to go up to -3, right? So 12, 5, 0, -3, -4. And then 2 is -3, 0, 5, 12. So first of all, do you notice anything about the table? Maybe the y values of the table. It repeats itself, right? It's a mirror image at some point. Okay? You think that might be important? Yeah, me too. Okay, we'll get there. So let's plot our points that we know. So -3, 12. So obviously we got to go off the graph a little bit, right? -2, 5. -1, 0. 0, -3. 1, -4. 2, -3. 3, 0. 4, 5, and 5, 12. Wait, can I connect these points? How do you know? Give me 2 ways you know. It's a function. It gives us an equation. The other way you know it because it tells you to connect them. Whoa. Sorry about that. Ignore this line, okay? Yeah, to ignore it. Yeah, I'm sorry, I put an arrow to ignore. All right, the point where the graph turns, do you know what it means by turns? It's going down and down and down and down and down. and then it's going up and up and up, right? So it's changing directions. It's called the vertex. What are the coordinates of this vertex? 1, -4. Very good. Okay. In this case, do you think this point would be called a maximum or a minimum? Why do you think it's called a minimum? So in this case, the vertex is a minimum because why? It's the lowest point. Does that make sense? It's the lowest point. When would it be called a maximum? What would a parabola have to look like to have a highest point? Oh, it would have to be upside down. It would have to be reflected, right? Very good. It would have to have a negative in its equation. All good answers. Very, very good. The graph is symmetrical to a vertical line through the vertex. A vertical line through the vertex. Vertical line through the vertex would look like that, right? Can you even see that pink? Pretend you can see it. That better? Not really. Okay. So I drew a dotted line on the graph. Why did I draw it dotted? Because it says. Does it really exist there? No, we're just kind of putting something in as kind of a reference line, right? Okay. Write an equation for this line. Well, if you'll remember, we write equations of horizontal and vertical lines by saying which axis it crosses and where. Which axis is this crossing? It's crossing the x-axis. Where is it crossing the x-axis? At 1. What does that have to do with the vertex? Isn't x equal 1 in the vertex? Yes. Okay. Any questions so far? Okay. What point is the y-intercept? What's a y-intercept again? Where it crosses the y-axis. That would be that point right there, right? So that would be 0, -3. Okay. Where does this number appear in the original equation? Oh, look. It's C, right? It is C. When we have y equals ax squared plus bx plus c, right? So what point has the same y coordinate but lies on the other side of the axis of symmetry? Well, here's the y-intercept, here's the axis of symmetry, so where's the point opposite that? Right here, right? So right there. Looks like a face. You look like a face. Okay, so 2, -3, right? 2, -3. Okay. There are 2 x-intercepts. What are their coordinates? So -1, 0 and 3, 0. Okay. So -1, 0 and 3, 0. Okay, so far. Find the factors of this expression. So remember when we spent that whole unit on factoring and you're like, we're so glad this is over. And I'm like, it's not. What two numbers multiply to be -3 and add to be -2? X minus 3, x plus 1. Right? Okay. How do the factors compare to the x-intercepts? What'd you say? That's exactly right. Look, x minus 3 and an intercept is 3, 0. X plus 1, intercept is negative 1, 0. So they are opposite numbers. Can we start with that? How could we make them be opposite numbers? Can I show you something real quick? Watch if I took this factor, x minus 3. What happens if I set it equal to 0? OMG. So if I give you the factors, can you tell me the intercepts? How? By setting them to 0. Very good. If I give you the intercepts, could you tell me the factors? How? Changing the signs and putting them in like a factor form, right? X minus 3, x plus 1. Does that make sense? Excellent. So we just kind of talked about J. Okay. It says write a generalized rule for finding a quadratic equation given its oh my gosh, I can't even read. Given its x-intercepts. So if I have an x-intercept of, what do you want to say? 2, 0? What would I do? What would I change that into? To a factor, x minus 2, yes. And then if I had an x-intercept of, let's say, negative 5, 0, what would that become? So it would be x plus 5. And then what would I do with those two factors to find the quadratic equation? I would multiply those two together, wouldn't I? Multiply. Does that make sense? Good. So how does the graph show that the equation is a function? How do we tell if something's a function? That's a good guess. If it's set equal to y, that tells me I can try to graph it, right? How do we know if something's a function or not? There's two ways that we talked about it. The first way is the vertical line test, right? How does the graph show that the quadratic is a function? So first, it passes the vertical line test. But what does it mean to pass the vertical line test? It doesn't touch my pen. I agree with that. But say that again, please. Every x has only one y. So great. I'm so glad you remembered that. Okay, that's so important when determining a function or not. So why is this function called quadratic? Because Mrs. Kingston said is not a good answer. No. So maybe something to do with the parent function? Okay, but what makes it quadratic? Oh, so it makes a parabola? It makes a parabola? Too many times that we get caught using pronouns, it. What makes a parabola? The equation. If we put it into a graph, that makes a parabola, right? Okay. Can you tell me any other way you know it's a quadratic? What if we couldn't see the graph? What if all we could see was the equation? No. The highest exponent is a what? A 2, a squared. Okay? Does that make sense? Anything bigger than that, if this was a cubed, if it was a 3 or a 4 or a 5, that is not quadratic anymore. Okay? It could have a squared in it, but if it has anything higher than a squared, that's not a quadratic anymore. Okay? What? Huh? Okay. Questions about that? Okay, go to the other worksheet real quick, please. We talked last week about two different forms, standard form and vertex form. Okay? This is a really messy chart about how to find all this stuff. Okay? Go back to this if you're struggling. I want to talk you through some of these problems, like starting on the next page, some of our example problems or sample problems. We may refer back to this. Like in standard form, you're going to have to know this. The negative b over 2a. See how it's part of two different things? So we got to know the negative b over 2a. We'll get there. Vertex form we talked about last week, h and k, so hopefully you remember that stuff. But like I said, we'll probably refer back to this table here in just a second. Let's go ahead and get started with what we know. How about that? Okay. So starting on A. Is this equation in standard form or is it in vertex form? Standard form, right? It's in the form ax squared plus bx plus c. Okay? So, like I told you a minute ago, we'd have to refer back to it, but I still remember it, so that'll help. Negative b over 2a. Okay? Negative b over 2a is going to give me the x coordinate of the vertex. Okay? Well, if I know this goes A, B, C, what is B? B is 6, so negative B? Negative 6 divided by 2 times A, which is negative 1. Does anyone know what 2 times negative 1 is? Excellent. What is negative 6 divided by negative 2? 3. So the vertex looks like 3 something. So if you know what x is, how could you find y? Plug it in, right? Now, we could do that or we could use our senses a little more wisely. Or the things that we have available to us, we could use those a little bit more wisely. Okay? So I want to get rid of my table, so I need to get my cursor up on the screen. Cursor, where are you? There it is. I need to click on my graph so my graph is highlighted. See how that's darker now? And I need to press Control T to get rid of my table. Okay? I want to hit Tab so that my equation line comes up. I want to tab up to Y1 or to F1, and I want to delete this one. Okay? I want to enter my new equation. Negative x squared plus 6x minus 2. Did you expect it to be upside down? Good. Okay. I could calculate my maximum. Okay. I could do menu, do some analysis of my graph, like number 6. Whoa, what are you doing? Sorry. And calculate my maximum. See that? That's my maximum point. It's actually not shown on the graph right now, so I'd have to be careful of that. I may need to change my window. But I don't want to do that because I already know part of my vertex. I already know the x is 3. So what happens now if I go Control T? If I know x is 3, what's y? 7. Okay? But here, let me show you something else real quick. Let's say I don't have my calculator and I forgot about Desmos.com. Okay? If I take right here and put in 3, what's 3 squared? What's 9 times a negative 1? Negative 9. What's 6 times 3? Plus 18 minus 2. What is negative 9 plus 18? Positive 9? Minus 2? Oh my gosh. Booyah. Okay, like Stuart Scott. He's amazing. What do you mean, who is that? He's a sportscaster on ESPN. He's hilarious. He says booyah. I know Cyborg says it too. I'm not arguing about that. I'm just saying he says it too. Okay, so vertex is negative b over 2a. That gives you the x coordinate. You have to go find the y. Okay? Axis of symmetry, though, just like we talked about a second ago on this problem, if I know the x coordinate of the vertex, don't I also know the axis of symmetry? Okay? So if I know that x coordinate is 3, what's the axis of symmetry? X equals 3. What's my y-intercept? What did we figure out over on this page? Our y-intercept is c. So this is in standard form, so I can just look at c. What does it look like, though? A y-intercept is a point, so it will be 0, negative 2. Very good. So what's the point symmetric to the y-intercept? Okay, here's the deal. You guys know how visual I am, don't you? Okay, so to do this one, I really have to do the graph. There are some people in this room, there are some people in my other classes that can see this right in their brain. I got to see it on my graph. So I'm going to skip this one for just a second, and I'm going to skip this one for just a second because I want to talk about it in relation to the graph real quick. Okay? So I'm going to graph this. Well, my vertex is at 3, 7. Right there. And I know it's upside down, but I also know its parent function shape. So can I go over 1, down 1? And over 2, down 4? Because that's parent function shape, right? And over 3, down how much? 9, right? Because 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 1, down 1. Over 2, down 4. Over 3, down. Now, did I expect my y-intercept to be right there? Oh, yeah, I did. Look, because that's my c, right? So here is my parabola. And here is my axis of symmetry, right? Why do I keep picking colors that you guys can't see? Sorry about that. If that's my y-intercept, then the point on the other side is right there, isn't it? So it's 6, negative 2. See what I'm saying? Okay. Now, my x-intercepts are going to be where? Where y equals 0. Does that make sense to you? Okay. So, how am I going to figure out where y equals 0? Well, if I rewrote the equation as 0 equals negative x squared plus 6x minus 2, I could try to factor it. So AC would be a positive 2. So what two numbers multiply to be positive 2 and add to be 6? Yeah, I can't think of any either. Okay, so we would have to use the quadratic formula to solve for those. Okay, and because they're x-intercepts, they're going to look like something 0 and something else 0. I can tell there's going to be 2 of them, right? So that's why I wrote myself 2 points. But I would have to get some paper out and do quadratic formula, which you will eventually have to do. I'm just worried about time today. Okay? And then I could actually go to my calculator and get a table of values. But look, because I already knew that this was parent function shape, can't I fill in a table of values for myself? 0, negative 2, 1, 3, 2, 6, 3, 7, 4, 6, 5, 3, and 6, negative 2. Guys, did you see me count these? It's because I didn't. What do I know about a table? If this is the vertex, my y values are going to be like a mirror of each other. Remember, like we talked about a little while ago. Okay? So I made sure that I was on the right x value, and then I knew what the y value should be. Okay? So what about b? How is b different? It's in vertex form, right? It's in vertex form. So the vertex should be super easy for me to find. The vertex is HK. What is H? Remember it's x minus h squared plus k? So it's -1 and 3. Very good. Where's my axis of symmetry? X equals -1. Where's my y-intercept? Ooh, not as easy to see this time, is it? Y-intercepts are not as easy to see. So that may be something we find after we graph, right? So I know my vertex is left 1 and up 3, right? I do have a multiplier of 2, though, so I have to be super careful there. Let me show you real quick what I need you to do for homework before I let you go too far. What I want you to do is 1 and 2 and 3 and 4. Okay? We will do 5 at another time. You may if you want. You can do 5 if you want, but we will be doing 5 at another time. Okay? I hope you have a great day. Do you want me to finish this on the video real quick? Finish that problem? Okay, let me finish this problem real quick so you can go watch it tonight or later on. Okay? So I'm going to go ahead and graph this point. -1, 3. That also tells me that my axis of symmetry goes right here. Okay? So because I know that it's not parent function shape, it has a multiplier of 2. Instead of going over 1 up 1, I'm going to go over 1 up 2 because 1 times 2 is 2. Instead of going over 2 and up 4, I'm going to go over 2 and up 8 because 4 times this 2 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And again, I know parabolas are symmetric around their axis, so I can draw it like that. Okay, so that definitely gives me 5 points for my table here. So that gives me -3, 11, gives me -2, 4, -1, 3, which I knew already from my vertex, 0, not 4, it's 5, sorry about that, 0, 5, and 1, 11, okay? So that tells me where my y-intercept is because I can see it. That's at 0, 5. The point symmetric to that point across the intercept is -2, 5. Y-intercepts. Y-intercepts are where the graph crosses the y-axis. My graph doesn't cross the y-axis, and I'm pretty sure I didn't do anything wrong. So there is a time that we are allowed to have no x-intercepts because it doesn't cross the x-axis. Okay? Come see me in the morning if you have any questions. There's the rest of the example. Remember, you're doing 1, 2, 3, and 4 of the practice problems. Okay? Have a great day.